In this video, we're going to look at lesson 1, 2, which is all about mathematical expressions. So you can see the learning objectives here: know how to identify expressions, be able to evaluate expressions, and use order of operations to simplify expressions. So basically, mathematical expressions are where we start using algebra extensively. And by algebra, I mean we're using this symbolic notation that let letters and expressions and other elements be stand-in for numbers. That's really what algebra is doing. It's basically letting variables be stand-ins for numbers. So we could give some expressions if we want. Here's some examples of expressions, mathematical expressions here. It's essentially a collection of numbers, symbols, operators that show a value of something. So you can see lots of different mathematical expressions here. So what we see here is numerical values, mathematical operators, and variables, all kind of interchanged. Lots of different mathematical expressions are going on. Lots of different mathematical expressions are going on. Lots of different mathematical operations are going on in each of these expressions. Okay. Now we're going to start evaluating mathematical expressions. And the word evaluate just means to find the value of something. So evaluate, the word evaluate in this section means find the value of the expression. So we're going to find a value of a particular expression, like for instance 5x minus 7 or like 4x squared. Now when we do that, we need to know is the value for the variable in question. For instance, if I'm trying to evaluate 5x minus 7, I need to know the value for x. If I'm trying to evaluate the expression 5a plus 4b minus 13, I need to know the value for a and the value for b. Okay? Now, once I know those values, I can, quote, plug those into the variable and the place for the variable. And then I can just utilize all of the mathematical operations in place to figure out the value. Now, here's the deal. When you use the mathematical operations, there's a hierarchy of what you need to do. So the first thing you need to do is you need to look inside of parentheses and brackets and simplify what's inside of the parentheses and brackets before you do anything else outside. The second level of operation, so the second thing you do is you evaluate any exponents you see around. On the third level is the multiply and divide level. So you multiply and divide accordingly. Now notice that these are on the same level. I'll say something about that with this first example here. And then on the very bottom level is the add subtract level. So on the add and subtract level, again, you add and subtract there. So this is what you do. Simplify inside of parentheses first, do any exponents you see next, multiply and divide, and then add and subtract. So there's 4 levels. By the way, there's other mathematical operations that are inside of each of these levels. For instance, taking the opposite is on this third level. It's the same thing as doing a multiply. So each level, these are the operations that we're going to see: parentheses, exponents, multiply, add, and subtract. But we're also skipping over some other operations that you would see in higher level mathematics that would fit inside one of these levels. Now, notice that multiply and divide and add and subtract um, are on 2 different levels, but the multiply and divide are on the same level, and the add and subtract are on the same level. So the question arises, what's going to happen when I have to choose between addition and subtraction? So for instance, we look at an expression like this, x minus 3 plus y minus 6, and we want to evaluate that when x is 4 and when y is 6. So what we would do is we'd plug in 4 where I see the variable x here. Usually we do that inside of parentheses. And I plug in the 6 in for the variable y. And again, we do that inside of parentheses. Oh, they plugged in a different thing. Well, that's not fun. Let me push pause real quick and go. They obviously made a typo. They plugged in 15 into where the y is. But I'll do this where I plug in 4 and 6. Do that, x minus 3 plus y minus 6 when x is 4 and y is 6. So x minus 3 plus y minus 6 when x is 4 and y is 6. So what I'm going to do is I'm going to replace this x with a parentheses, and I'll plug in 4. So x, I put in parentheses the number 4. Obviously the minus 3 stays the same. Whoops, let me do this a little bit different. So put in 4 in parentheses, do the minus 3 I said, plus now y is 6, so in parentheses, I'm going to replace the letter y here with the number 6, and there you go. Now here's the deal. Because addition and subtraction are on the same level, what I need to do is I need to work my way from left to right. So I don't want to add this 3 and the 6 immediately. What I want to do is I want to take 4 minus 3 first. So 4 minus 3 is a 1 plus 6 minus 6. And then I would, in the next step, go 1 plus 6. That would give me a 7. And 7 minus 6 obviously is 1. Now, again, order of operations does that. We need to know how to do that. We need to know what is happening to get this final answer of 1. However, your calculator is going to obey the order of operations as it sees it. So what I mean by that is that if you put in 4 minus 3 plus 6 minus 6 into your calculator, it is going to understand how to do order of operations and actually come out with 1. So if you want to, you can plug that all into one line on your calculator, and it should give you a 1. And that's basically the whole thing. So we have 4 levels: do parentheses, exponents, multiply, and add. Multiply and divide are on the same level. So if we ever have a choice between multiplication and division, we're just going to work ourselves left to right. And add and subtract are on the same level. So if we have a choice between addition and subtraction, we'll just make our way from left to right. And that's basically the most part of this first part of 1-2. Now, obviously there's some intricacies when we get into the actual evaluating the expressions. So what I'm going to do is I'm going to do the problems on starting on this page, page 21, and then 22 as well. Okay, these are the instructor-led problems. There's also some cooperative group problems that you could try as well. I'm not going to do those, but I am going to do the instructor-led problems. The cooperative group problems are very similar. So let's actually start doing that. This is just a Word document so that I can type things in. So question number 1 says evaluate 5x minus 3 when x is 3. So what I'm going to do is I'm going to go 5, and then in parentheses, I'm going to replace this letter x, this variable x, with the number 3. minus 3. Now, if we wanted to do this order of operation style, I'd take 5 times 3 first, get a 15, and subtract 3 and get a 12. The other thing you can do is you can just type this into your calculator as it shows there, 5 times 3 minus 3, 5 in parentheses. By the way, your calculator is going to know that when you have parentheses here, that we're talking about multiplication. So either way, whether you're typing it into your calculator or whether you're doing it by hand, you're going to end up with a 12. By the way, it's this reason that every time that I plug in a number for a variable, I use parentheses. Because if I didn't use parentheses, it would probably look like a 53, right? Or it would look like 5 maybe plus 3, and you could get thrown off by that. So that's why we always use parentheses, because when, especially in this case, a 5 next to an x really means 5 times x. So 5 next to a 3 should mean 5 times 3. So there you go. On problem number 2, we're going to take 5 multiply times negative 4 and then subtract 3. Again, you can type this into your calculator. 5 times negative 4 minus 3 is negative 23. And that's the final answer. Now, usually, by the way, on Moodle, when you're actually going through the problems, it'll say write your answer in this box. On the test, generally speaking, if it's a handwritten test, it will say, hey, write your answer on this line. So it'll say something like answer is, and then put a line there. And you would just write you just write the number 12. Okay. It's really hard to do on Microsoft Word here, doing it well. All right, we come to the third problem, and the third problem is kind of an interesting one in that we have pi in it. All right, so pi, r squared, we have 4 as our r in this case. So pi times 4 squared. Now, hopefully you've seen pi before. It has to do with circles. It's actually always the ratio of the circumference of the circle to the diameter of the circle. It's a little bit more than 3.14, but it's an irrational number, which means it goes on forever and ever and ever in terms of decimal places. And there's no repeating, so I can't write it as a fraction. So I have a couple of options here. The one we're going to use in this class is that we're going to use the pi button that's on our calculator, and then we're going to round our answer to maybe 2 or 3 decimal places. Let's say we're going to round this one to 2 decimal places. So what I would do is in my calculator, I'd put pi and then parentheses 4, parentheses squared. Now, let me show you how to do that. So here we go. So here's a calculator. I've already typed this in for us. Pi times in parentheses 4 squared. Now how I get this pi is right here on your calculator. There is a pi button. You can see it there. So I type in pi and then obviously parentheses 4 in my parentheses. And then to get this little caret key, that's right here. That's your exponent squared. Now, if you had to do this by hand, you'd have to square the 4 first, and then you'd have to multiply it by pi. But our calculator is going to do that all for us. If we hit enter, you get 50.26548.246, which, whoops, when you round that to a couple of decimal places, is something like 50.27. All right, that's the rounded answer. By the way, sometimes people, when they write a rounded answer, will write squiggly lines instead of just the normal equal sign. So a lot of times I'll write squiggly lines for to just show that that's been rounded. But other times, I'll just write an equal sign and not worry about the difference. All right, now these first three, we only had one variable to plug in, but obviously we can have expressions with lots of variables, like, well, start out with L times LW. Notice the LW are right next to each other. When I plug in 8 for W and 12 for L, I plug them in parentheses, and all of a sudden it becomes abundantly clear that LW means L times W. Um, this is again just something you type into your calculator. You'd end up 12 times 8 is 96. So 96 is the answer to problem number 4 there. Here 4x squared plus 5x minus 2. When you plug in something, especially when we're dealing with squared stuff, be really careful that when you plug in, for instance, this -7, that when you plug in the -7, this caret 2, which you're going to put on your calculator, is outside of the parentheses. If you put in a caret 2 on the inside of the parentheses, it's going to give you a wrong answer. So make sure when you plug in x, the entire -7 gets squared. So you'll do that by, when you type in the caret 2, do that on the outside of the parentheses. So what's that? Plus 5 times -7 minus, minus 2. All right, so there you go. And if you type this in right, it's a pretty straightforward type in. But if you type this in right, I believe you get 159. 159. Again, be very careful how you type in this -7 squared. If you didn't write those parentheses, you'd end up with like a -233, which is completely wrong. All right, so make sure you write this -7 and then all that in parentheses, and then the squared being outside the parentheses, or the caret 2 being outside of parentheses. Here's another little twist that we're going to come across this semester. This is what happens when we get x1, x2. Well, notice that first off, these little numbers are below and to the right of the variable. What this means, this doesn't mean x to the first power. This x sub 2 does not mean x squared, right? When the 2 is above and to the right of the variable, that means squared. But when the 2 is to the bottom right, what this means is just this is my first variable and this is my second variable. So it's kind of like someone saying, well, let's take a minus 4b, where a is my first variable and b is my second variable. So this x1 is just the first variable. x2 just is a stand-in for the second variable. So all we have to do, we're going to treat x1 just like we would any other variable. We're going to put it in parentheses, put 6 in parentheses, and replace x1 with that. And then x2 we treat just like any other variable. We put 30 in parentheses and replace x2 with that. So we go 6 minus 4 times 30. Order of operations, if you plug it in on your calculator, is going to take over. You're going to get -114. We can do the same thing here on problem number 7. On problem number 7, the first variable is 4.2, so we're going to take 3 and then in parentheses 4.2. And by the way, I'm typing this in onto my calculator exactly the same way. I'm using parentheses each time. That's always, I just like to be consistent every time I do something. So 3 times 4.2 minus 10 times 3 times 4.2, I should have done that, minus 10 times 2.3 is negative 10.4. Now this one started with decimals, so I'm just going to leave my answer as a decimal. Okay. Same thing. This one I could not have converted to a fraction. I had to round it. So I just rounded it. Everything else has been whole numbers answers. Let's take a look at another one, number 8 here. 8 starts dealing with our variable is in the exponent. Okay, you'll learn maybe later in mathematics courses that that's is called an exponential function because the variable is in the exponent part. So it's an exponential function, or I should say an exponential expression. So we're going to go 4,000, 1.08, and then caret, we plug in 15. If you want to plug in 15 in parentheses, that's perfectly fine. But being that it is already in an exponent, I actually don't need those parentheses this time. Again, it's not going to hurt if you plug the exponent into parentheses, but excuse me, but it's not a dire necessity like it is when we're dealing with multiplication. Now I type these expressions in all in one line on my calculator. So I do 4,000 parentheses 1.08 in my other parentheses and then do caret 15. So I like doing this expression all in one line on my calculator and then coming up with an answer. Now this answer has a really ugly decimal, so I don't want to actually write down the whole decimal. I'll just round it again. So what I'm going to do, oops, I'll round this again to about 2 decimal places. 12688.68 when I round that to 2 decimal places. So there we go. By the way, when you're typing things in on Moodle, if your answer does come out in the thousands, don't put a do not put a comma in on Moodle. Moodles aren't really recognized. Did I say Moodles? Commas aren't really recognized by Moodle. So when you're writing it in on Moodle, write 12,688 without a comma. If you're writing this down by hand on a test, then it's perfectly fine to use a comma so you can see that that means 12,000. All right, here's another one. 5/9 f minus 32. So we're going to take 5/9 times 82 minus 32. Order of operations dictates that I have to simplify what's inside the parentheses. In this case, the 82 minus 32 first, and then multiply by 5/9. But again, if you type it in just in this way perfectly into your calculator, or another equivalent way, you can still get the right answer. All right. Now I'm going to convert this to a mixed number and an improper fraction. Hopefully you remember how to do that. If not, let me actually remind you now. So we have a decimal place right now. And if I want to go from fraction to decimal, I hit the second button, second, and then this FD here. So second and PRB, second PRB. The thing I got is 27 and 7/9. That's the mixed number version of this. If I want the improper fraction, I'll hit second, and then again this ABC to DE button. So second, and then this. And as an improper fraction, that's 250/9. So if I want to write this as an improper fraction, 250 over 9 is the way to do it. All right, let's look at the next expression. Here, evaluate mx plus b when m is 2, x is 0, b is 6. So when m is 2, replace m with a 2. X is 0, replace x with a 0. B is 6, replace b with a 6. And when you type that all in, or when you just do it in your head, 2 times 0 is 0, plus 6 is 6. So answer there is 6. Number 11 here. Number 11's an expression that we're going to deal with later. Y2 minus y1 over x2 minus x1. So we're going to have a fraction. Y2 is the first number, that's 7, minus y1, which is a 3, all divided by x2, which is a 5, minus x1, which is the number 2. Now this one is a little bit tricky, okay? If on your calculator you were to have typed 7 minus 3, and then you would have hit your divide sign, and then you would have hit 5 minus 2, your calculator would have interpreted it just like my computer program interpreted it. It would have thought you meant take 7 minus 3/5 minus 2. Obviously, that's not what we want. What we want, we don't want 7 divided by, we don't want this. Because if I type this on my calculator, it'll think that this is the thing I do first. Remember, order of operations says do division before subtraction. However, because this this is a fraction here, what we need to do is we need to simplify the top first, and then simplify the bottom next, and then simplify the fraction, or at least get what we want to. So what I would do is I would have said, well, 7 minus 3 is 4. Let me space this out a little better. 4. 5 minus 2 is 3. So 4/3 is my answer. You always simplify the top, simplify the bottom, and then do your division. And the reason for that is that this sort of a thing, this separator of a fraction isn't just a divide sign. It's a divide sign plus a separation of a top piece, specifically the 7 minus 3, and the bottom piece, specifically the 5 minus 2. Now, if we want to use the improper fraction for the answer, that's it, 4/3. If you wanted to use a mixed number, it would be 1 1/3. If you wanted to round it to a couple places, it'd be 1.33. So there you go. Evaluate p times 1 plus r to the t. Let's go ahead and do that one. P is 3,500. 1 plus r, 1 plus 0.08. By the way, you're going to easily see that these parentheses right here, you're plussing a 0.08 in parentheses. Not real necessary to have those parentheses if you don't want to put them. And then all of that and then that is to the 10th power. Now, if you're doing this by hand, make sure you do the 1.08 first, combine that, then take the exponents next, because again, what we're doing is simplifying inside parentheses, then doing exponents, then doing your multiply. So the last step should be multiplying 3,500. If you're doing this on a calculator, Then you just type it in all in one line, 3500, in parentheses 1 plus 0.08, end your parentheses and go caret 10. All right, we've seen that before. Now you're going to have to round it because it doesn't have a nice fraction dealing with it, but it's about 7,556.24. Okay, rounding to 2 decimal places. All right, let's do this last expression. So evaluate n minus 1 times x to the n minus 1. Whoops, do that when n equals 4 and x equals 3.7. So we're going to plug these things in, and we're going to figure out that there is one thing I have to really worry about. So we're going to go 4 minus 1 in parentheses. X is a 3.7. And then my exponent here. Now here's the deal. Oops, I screwed that up. If in my calculator I put 3.7 caret 4 minus 1, what's going to happen is that my calculator is going to interpret it that way. So if I put 3.7 caret 4 minus 1, it's going to think we want to take something to the 4th power and then afterwards subtract 1 from it. So what I need to do is I need to make sure that 4 minus 1 actually all happens in the exponent. Now there's a couple ways I can do this when I type this into my calculator. First off, utilize my parentheses. Let me see if I can do this. I can type in 4 minus 1 parentheses 3.7 and then my caret, and then I can put the 4 minus 1 in parentheses so that my calculator knows that that 4 minus 1 is all in my exponent. All right. The other option I have is I can just say, well, let's by hand take n minus 1. N is 4. So let's just take this exponent, and when I type it into my calculator, type it in as just 3 already. All right, so 4 minus 1 times 3.7 to the 3rd power. So if you do that, what you're going to end up with is a 151.959. And that's the final answer to question 13. By the way, all of these expressions that I've been dealing with here, like x to the n minus 1, you think, well, where does that ever come up? Well, if you ever go into calculus, you'll see some x to the n minus 1, although with a different coefficient when you're doing derivatives in calculus. P times 1 plus r to the t, that's a compound interest formula that you may see later on not in this class, but later on in another math class. We are going to see this formula, y2 minus y1 over x2 minus x1, in later sections of this course. That has to deal with slope of a line. mx plus b, that again has to do with a line. 5/9 f minus 32, that's actually the expression that converts from Fahrenheit to Celsius degrees. This is another compounding interest formula. And then 7, 6, those are just expressions. 4 is the area of a rectangle, LW. And then pi r squared, that's the area of a circle. So some of these expressions that we've dealt with, we're going to use later on in the semester. Other expressions we won't see, but other ones are famous. For instance, converting Fahrenheit to Celsius or compound interest formulas. So there you go. That is at least the first part of section 1, 2. Now, try some cooperative group problems on your own. You can try these. If you have questions over them, then contact me. Those are for you to do. And then obviously at the end of the section, there's some at-home stuff. We'll start the second half of 1, 2 in the next video.